multiplying integers, I kind of like a table for this. If I have a positive and I'm multiplying another positive, what sort of a result can I expect? A positive. And if I've got a negative and I multiply times another negative, what kind of result do I get? Positive. And that's kind of weird. If I'm multiplying a negative times a negative, I have to think of a good way to maybe phrase that. If I have a positive times a negative, that's going to be a negative. And if I have a negative times a positive, that's also a negative. So there's a pattern in here. If you're multiplying and you have an odd number of negatives, your answer will be negative. An even number of negatives, your answer is positive. So I don't think you're going to be asked a question like this, but I think it's good for an example. What if I said, what's negative 3 times negative 2 times negative 6? Is it going to be negative or positive? Negative. Yeah, you have an odd number of negatives. Or you can think of this, you can say a negative times a negative is a positive, but then a positive times a negative is going to be a negative. And then what do I get? I think that's 36. Pretty sure. There is. Right. Okay. So, oh yeah. Yeah. Aaron, wake up. When you're doing a job for some guy or girl, your boss comes to you and says, Aaron, what's negative 5 times negative 3? I want you to be able to blast out that answer with confidence, not go, I think I slept through that lesson. Right? Okay. Checkpoint. Probably your boss isn't going to ask that question exactly. But you never know. Let's see. There's line in figure 5.5. Wait a minute, that's not what I'm looking for. Where's my checkpoint? Here we go. It doesn't have a checkpoint. I hate when they do that. That's alright. How about this? Three times 4 is 12. Negative or positive? Negative. Good. 11 times 9 is 99. Negative or positive? Positive. Right. Do I need to write the plus? No. But I could. Right. It wouldn't be wrong if I did. It's just not necessary. Alright, and division. It's exactly the same thing. A positive divided by a positive is going to give us a positive. A negative divided by a negative is also a positive. Why is division the same as the multiplication rule? Exactly. They're relatives. They're like closer to the brother. Yeah, it's basically the same thing, because you can take and use a multiplication problem to replace a division problem and vice versa. So the same thing's true. Odd number of negatives equals a negative. Even number of negatives is a positive. Okay. I can't really see us having 3 division signs in terms of a fraction, but you might see something like this. Excuse me. All right, the last thing that we're going to talk about, and probably the thing that really does hang people up, whether you're good at math or not, is order of operations. Order of operations is just this rule that you have to memorize, and then at that, it seems like it breaks itself here and there. So, what's a way that you guys have learned to remember the order of operations? PEMDAS, right. Almost everybody learns PEMDAS at one time. And the P is for parentheses, or any kind of grouping symbol. Even these guys sometimes. E is for exponents. So maybe x to the y or something like that, exponents. M is multiplication. D is division, addition, and subtraction. Please excuse my dear Aunt Sally, all that stuff. If you remember it like this, and you use it just like this, where this is first and this is last, you're going to get some problems wrong. Yeah, you're going to get some problems wrong. And so I've never really been that big of a fan of teaching multiplication or order of operations this way. It works, but what you have to remember is that multiplication and division, they're really the same thing. So that is from left to right. And addition and subtraction is also left to right. And there's also some more details here. How about the parentheses or brackets or whatever? What order should I take those in? Inside out. Yeah, inside out. Innermost. And there's something that's totally missing here, because kind of like multiplication and division, it's the same as exponents. Roots, exactly. Yeah, roots. And there's no, I've never known of a problem where you do one before the other. It's just kind of left to rightish, I guess, more than anything else on that. Yeah, yeah. There's no preference there. So how I like to rearrange this is simply 1, 2, 3, 4. Now you don't have to remember it this way. I'm just giving it to you a little bit differently. To me, there's 4 things that we've got going on here instead of 6. And the first thing being the brackets, parentheses. The second thing being our exponents or roots. Third thing, multiply or divide. And again, left to right. And then add and subtract from left to right. And I'm more visual than mnemonic. So, yeah, I know PEMDAS, I know what it means and all that. But I think for me as a student, I would remember 1, 2, 3, 4 better. Just, that's me. It may not be true for, it certainly isn't true for everybody, but this is how I see my world. So when we have problems like this, I'll get where you can see that. 3 plus 7 times 5, I oftentimes have students go, oh, well, that's 10 times 5 is 50, but that would be incorrect. Because our order of operations says we've got to do the multiplication before the addition. And what if I did 8 divided by 4 times 2? What a lot of people will do is they'll go, oh, I hate division. Oh, multiplication's easy. I'm going to multiply. So 4 times 2 is 8. 8 divided by 8, oh, that's easy. It's 1. But that would be incorrect. We're going to divide first because this is a left to right problem. 8 divided by 4 is 2 times 2 is 4. Yeah. I don't think the problems today get terribly involved with order of operations. Certainly I don't expect you're going to see too many exponents, but I had a thought. I was going there and now it's lost. I've lost. Oh, when it seems like you can break the rules is when you have a fraction. What if we have something like this? 8 plus 3 divided by, that's going to be ugly. How about I say times? Divided by 5 plus 4. I have no idea if that's going to work out evenly. I don't really care. But the order of operations, if you follow it strictly, you're going to say, okay, I'm going to multiply the 3 times 2, and then I'm going to try to divide this. But you can't. It's a fraction. What you do is you simplify the top, you simplify the bottom, and then you divide. So the top is sort of its own problem. And there are times where it looks like you can simplify, but when you've got those pluses in there, or divide before you finish up, when you've got those pluses, it goofs with you. So what do I have? 8 plus 4 is, 8 plus 6 is 14, divided by 9, and I can't really do anything with that. I'll leave that alone. I kind of didn't think off the top of my head problem would work out. So save the division in a fraction for last. Yes?
This is interesting. Can you talk about that? I think
That's true. That's true. And in fact, I see where you're going with that. With parentheses, oftentimes you can add them, or sometimes they're there and they're not necessary too, right? You can throw that in there for sure. It is like there's parentheses. Yeah, good point. Okay. So finish these guys up.